Okay, terrestrial ecology notes. This is video 3. This is going to be slides 45 through 60. So I'm going to skip ahead to where we left off on slide 45. Okay, so we're looking at the relationships between animals. One of the main kinds of relationships is the predator-prey relationship between two different kinds of organisms, the prey organism and the predator organism. This is a cyclic relationship, so you see if you're looking at the prey organism, in this case the hare, you see the population, jumping and then dropping, jumping and dropping over and over, and what you see after that is the lynx population doing the same thing. So there will be always fewer lynx than hare because you have that 10% rule where you have fewer predators than prey. Right after the prey population jumps, the predator population will jump, and that in turn causes the prey population to fall, which in turn, after a little bit, will cause the predator population to fall, and so on. And it just continues this cyclic course between the two populations. So you see the same thing where you have this dramatic increase in moose population, which after an introduction to this area of the wolf to control the moose, you end up having the same cyclic population control. So the importance of population control: the predators are going after the sick, the weak, the old, excuse me, and they help to control the population, keep it healthy, make sure that there's a good available food supply or access to food supply for the rest of the prey stock, and it keeps the genetic stock strong. It's ensuring that the fastest, the best, the smartest, all of the best genes are getting passed forward because they're the ones that are surviving. Okay, so there's a lot of species interactions that we can look at. Competition between species, both in a good way and a bad way, predation between species. So some of the choices we have: competition, predation, parasitism, mutualism, and commensalism. There's adaptations that help species either reduce or even avoid outright competition for resources, essentially where they'll partition or share their resources with other species, but that happens much more rarely than the basic interactions between species. So let's take a look at those. So symbiosis, 3 choices, and this again is probably a review. Most of you guys are familiar with this already. Parasitism: one species benefits, the other species is harmed. The parasite is feeding off the host, either feeding off it. Usually parasites don't actually want to kill the host because then they wouldn't have anything to eat. So a parasite will usually feed off the host. They might make it a little weaker, or not quite as great as others of its species, but they're not actually going to kill it. The problem and the fatalities come when the parasite load gets too much, when there's so many parasites in one specific animal that it can't survive with all of them in there. Commensalism: one is benefited and one is just negated. It doesn't harm it, doesn't help it. It's just kind of there. And then mutualism is when both species benefit. Parasites are actually really a good thing when you think about them. They help biodiversity a lot. They make animals stronger. You can have parasites that live in the host, like tapeworms or bacteria, and you can have parasites that live outside the host, like fleas, ticks. The sea lampreys is a fish. Some parasites even don't really have much contact with the host, but are nesting in dung. That's a typo. They're nesting in dung, hanging out, in the same area, eating stuff off the host, but not really spending time on the host. So they really end up helping the community overall. They increase the biodiversity, and they really can increase the health of the host. Think about all of the bacteria that we have in our gut that helps us to digest food. I mean, that's what you're eating yogurt for, is to get that good bacteria in there, to make sure that we can fight the cold, fight the flu, that we have the good stuff, so when the bad stuff comes along, we're not as susceptible. Okay, so mutualism is a win-win. Some examples of that. You got the oxpecker birds on the black rhinoceros. They're picking off the bugs that are bothering the rhinoceros, so they get a nice free meal, and the rhinoceros gets parasites removed. The clownfish and the sea anemone, the clownfish gets protection as well as, and so does the sea anemone. And then you've got the fungi on the seedlings, and they actually help to increase growth because the fungi are producing food and sharing that food with the juniper, with the plant, but then the plant is giving the fungi a nice, safe place to live. Commensalism is one benefits than the other, doesn't really have any effect. So something like this, where your plant has a nice, why am I blanking on the term? It'll come back to me. Your plant has a nice, safe place to live is the point, and the tree that it's living on doesn't really matter to the tree, but this, not bryozoan, you guys know it, it's living up high and away from predators. Okay, so population growth cycle, if you have limited resources, we know already the population is going to grow until the carrying capacity is reached, until the resources are exhausted and there aren't enough. It's competition for the resources that's what's causing the carrying capacity to be where it is. It's animals competing with each other. So the phases you're going to see, again, if we look at that graph you guys have seen before, to review, you see the carrying capacity right here. Step 1, the population overshoots the carrying capacity. It's the lag, the birth rate has to match up to the death rate. And then you have your dieback, this is step 3 on this graph, and then you reach the carrying capacity and you usually kind of fluctuate right around it. And we've seen that before. The relationship with human population growth, there are definitely factors that have limited us in the past and still limit us. Infectious disease is one of the large ones that has caused us, to kind of bounce around a carrying capacity type thing. For example, bubonic plague has, if you look at human population, I'll go back. If you look at human population over time, we have that increase, and you see that drop somewhere around the 1300s before it starts to go back up again. This is the plague. So you see that where that huge die-off in the population because so many people were affected and the plague had such a high death rate that there was a drop-off in the human population before it continues. There are a few more, world wars and stuff, but there are definitely factors like infectious disease that can control human population. Habitat needs are a big source of competition. What do the animals and plants need as far as habitat? They need cover, shelter of some kind. They need water. They need nutrients, and food of some kind, depending on if you're an animal or a plant. Macronutrients are the chemicals that organisms need a lot of to survive and reproduce healthy. So we need a lot of carbon, we need oxygen for sure, we need hydrogen, nitrogen, calcium, and iron. These are the big nutrients, and I would for sure memorize these. Make sure that you know these and are comfortable with these. These 6 nutrients are the ones that we have to have in our environment in order to survive. Micronutrients are the ones that we have to have it, but we don't have to have as much of it. So again, I would make sure that you memorize these, make sure that you can list off at least a couple of them. We don't have to have as much, but we do have to have sodium, zinc, copper, chlorine, and iodine, just a little bit to make us healthy. That's why we take vitamins if we're not getting it in our diet. So the cycles, carbon, phosphorus, and nitrogen cycle, help to make sure that we're getting these nutrients that we need. It's a cyclic movement of the chemicals. This is an old PowerPoint, so you can ignore this right here, but you can review chapter 7, the cycles are in it, and look through, make sure you're comfortable, don't get bogged down in the details of these cycles. We're going to go through each cycle individually in a minute, but don't get bogged down with each cycle, what they, this specific bacteria goes here, this specific bacteria goes here. Know what goes in, what comes out, what are the main phases of the cycle. And all of them really, if you think about it, are some kind of plant, some form of this stuff is in the plants, and then the form is taken in by animals because animals eat the plants, and then it's decomposed into air or soil or water, and then from that it's taken back to the plant. So this is the basic cycle for all of these, and if you know this basic cycle, carbon starts in plants, moves into animals, eat the plants and get the carbon. When the animals die, the carbon is released into the ground. If you know this basic, it's the same for all the cycles, and now you just have to apply each of those to the different cycles. So this is looking at in the environment. You see all the cycles on land, both in the air, in the water, in the ground, right along the Earth's crust. The biosphere is above the cycles, so this is all happening below or in the biosphere. In the ground, we're losing heat from these cycles into the environment. And this is where everything is occurring, is right along the Earth's crust in the biosphere. And I think that is where we stop. Yes, we're going to stop there for today. Video 4 will go into each of the cycles in depth.